we've been looking at how to simplify rational expressions. Now we're actually going to look at how do we solve them. Now, we are only going to use this process when you have an equation, because with an equation, we have a balanced scale type system, so this will work. First thing we're going to do is we're going to find the least common denominator. Then we're going to multiply every term by the least common denominator. This should make all the denominators cancel out. Then we're going to simplify and solve it for our variable. So here's going to be our first one. First thing we need to do is find our least common denominator. So I need to go through and I need to factor each one of these items. Well, x is just going to factor into an x. The 4x will be 2 times 2 times x. The 20 would factor into a 2 and a 10, and then a 2 and a 5. And then the 5 is just going to be a 5. So when I get my least common denominator, I need the x, I need the 2 2's. I already have an x, so I don't need to double up on that. I already have 2 2's, but I need a 5, and I've already got a 5. So when I look at my least common denominator, it's going to be 20x. Now I'm going to take that 20x and I am going to multiply every term by it. Notice it's not 20x over 20x, it's just the 20x. When I look at this first set right here, 20x times 4x, or times 4 over x, my x's are going to cancel out, and then I'm just going to be left with 20 times 4, which is 80. Then I have a minus sign, and in my second set here, 20x times 3 over 4x, well, my 4 and my 20 will reduce to a 5 and to a 1. My x and my x will reduce, so I'm just left with a 15. And my next term, have a plus sign there. When I multiply, my 20s are going to cancel out, and I'm just going to be left with 1x. And on the other side of my equal sign, when I multiply, the 5 and the 20 will reduce down to a 4 and a 1. So I am left with 4x. Now I have a problem that has no denominators. I can simplify this, and then I can solve it. So I'm going to combine all my like terms. 80 minus 15 is 65. Going to subtract the x over. And then I'm going to divide both sides by 3. And I'm going to go ahead and just leave my answer as a fraction. It doesn't reduce, so I'm just going to leave it as 65/3. Now I need to go back in, and using my calculator, I need to check to see if this works. The reason I need to check this is because I can sometimes come up with an answer that doesn't fit into my domain. And if you look at what we started with, we had division in several spots. And based off of the fact that I'm dividing by x and by 4x, I could not have 0 for an answer, which I didn't end up getting this time. But if I had gotten x equals 0 when I solved this problem out, I would have to throw that out because it's not possible to divide by 0. When I plug it back in, it does turn out to give me 1/5. So this answer does work. Okay, here's a second practice one. We need to start out this one by finding the LCD again. Well, I need to come down and I need to factor both of these. So I'm going to have x plus 2 and x minus 2. And the x plus 2 is going to stay, and the 6 really has a 1 for a denominator, so we don't need to worry about that either. So my least common denominator, I'm going to have x plus 2 and x minus 2 from that first term. Then when I look at my second term here, I already have an x plus 2, so I don't need to double it. And the 1 we don't need to worry about. So my least common denominator is x plus 2, x minus 2. Now I need to take each term and multiply it by my least common denominator, just like we did on that last one. Oops. When I come back to my first, this x plus 2, x minus 2, x plus 2's will cancel out, x minus 2's will cancel out, so out of my first term I am only left with a 2. Out of my second term, the x plus 2 and the x plus 2 will cancel out, so I'm left with 5 times x minus 2. Very important to have those parentheses there. And on the other side of my equal sign, nothing cancels out, so I am left with 6 times x plus 2, x minus 2. Now I need to combine like terms and simplify it all out. So I need to distribute that 5 out first, so I get 5x minus 10. And then I'm going to FOIL the x plus 2 and the x minus 2 together, so I'm going to end up with x squared minus 4. I still have the 6 on the outside of that, so I'm going to distribute that 6 in now. So I have 6x squared minus 24, and then we're down to an algebra one. Now this one, I've noticed I've got x squareds and just a plain x, so I'm going to probably have to use factoring or the quadratic formula to solve this. But before I do that, I need to get everything to the same side. So I'm going to subtract the 5x from both sides because I want my x squared term to stay positive. So I'm going to have 6x squared minus 5x. I can't actually combine it with anything. Let's see, and then this 2 minus 10 over here would be a negative 8. So to bring it over to the other side, I need to add 8, and I need to add 8. That's going to give me a negative 16. So now I've got my quadratic set equal to 0. And now I can try to factor it or use the quadratic formula. I'm just going to go ahead and use the quadratic formula right away because I know that's going to work no matter what. So I need to take the opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all divided by 2a. When I multiply that out, I get 5 plus or minus the square root of 409 divided by 12. I need to go ahead and check that, so I'm going to plug it in to my original equation. I'm going to do the plus first and then the minus. Make sure you don't use a decimal here because otherwise it's going to make your answer off a little bit. So actually just use 5 plus the square root of 409 all divided by 12 when you go back and you plug it back in. Okay, when I finally got that all plugged back in, it did end up working out, so that's what we would have gotten for an answer on that one. Okay, here's a practice one for you. Go ahead and pause the video and see what you can come up with for this one. On this one, I found my least common denominator to be x plus 1, x minus 1, and then I multiplied every term here in green by x plus 1, x minus 1. Then I used the blue to cancel out and to rewrite my new equations. Then from here, I FOILed. This right here is a FOIL problem. And this right here is a FOIL problem. FOILed all those together. Then I went ahead and I combined like terms and did some algebra. Ended up getting x squared minus 3x minus 10 equals 0. On this one, I noticed pretty quickly that I could factor it into x minus 5x plus 2. If you use the quadratic formula at this point, that would be fine also. But I got my answers to be 5 and negative 2. And then when I checked them, they both worked. So we get to keep both of them for our answers. Here's another practice one. So go ahead and pause the video again and give this one a shot. Okay, on this one, I found my least common denominator to be x plus 1. So I multiplied every term here in the green by x plus 1, and then I used the blue to cancel out things that would cancel out. And I was left with 5x equals 4 times x plus 1 minus 5. When I simplified that out and multiplied that out, I ended up getting x is equal to negative 1. But we run into a little bit of a problem with that. When I plug it back in here, I'm going to end up getting negative 5 over 0 is equal to 4 minus 5 over 0. That is impossible. I am not allowed to divide by 0, so this one doesn't work out. This is an example of where that negative 1 is not part of my domain, so even though I did all the math right and got that for an answer, when I go back and check it, it doesn't work. So this would be one of those cases where we have no solution. Now, when we have these rational equations, there is one special situation that we sometimes run into, and it makes our process a little bit easier, and it's what I call a proportion style, and that's when we only have a single fraction equal to a single fraction. Like on these last examples, there was this +3 at the end, and there was this 4 stuck in there. Those aren't what I would consider proportion style. When you have a proportion style, you can solve it just like you used to solve proportions, where you do cross products. So I can cross multiply and have my equation. So I would take 2 times x minus 1 equal to 1 times x squared minus x. It's quite a bit quicker than going through our other process, but it only works in this format when there's a single fraction equal to a single fraction. If there had been like a +5 tacked on the end of this, we can't do it. Once you get to this point, then you can just distribute and then have an equation that you can solve. So I'm going to bring everything over here to where the x squared is, so I'm going to subtract 2x from both sides. And then I'm going to add that 2 on over because I have to get it set equal to 0. And so I have 0 is equal to x squared minus 3x plus 2. And with that one, I am going to factor it into x minus 2 and x minus 1. Then I find my answers to be x equals 2 and x equals 1. Now I still have to check them both. When I plug the 2 back in here, let's see, it is going to work out. When I put the 1 back in here, we have a problem. When I do 1 squared minus 1, I get 0, so I would have 2 over 0. And the same thing here, when I plug it in there, I would end up getting 1 over 0. That is not possible because I cannot divide by 0. So this 1 is excluded from my domain, so even though I got it for an answer, I have to kick it out. So for this one, we're only going to keep the x minus 2 answer. Alright, here's a second one that's a proportion style, so go ahead and pause the video and see if you can get this one figured out. Okay, when I did the cross products for this one, I had x times 4 minus x, I go diagonally, equals 5 times 2x plus 1. Distributed that out, and then I did my algebra. I brought this x squared over to the right because on the left side it was a negative and I want it to be a positive when I'm working with it, so I brought it over to the right side. Then I moved the 4x over and got down to this equation, 0 equals x squared plus 6x plus 5. From there I factored it into x plus 5, x plus 1, and got x equals -5 and x equals -1. When I plug them back in, they both end up working, so I can go ahead and keep them both. But now remember, you can only do this when it's a proportion style, a single fraction equal to a single fraction.